And now in this lecture we will find the radius of the small circle. In the drawing we have a square ABCD, and we know that AB equals to AD equals to DC equals to BC equals to 8 units. So one side of this square is equal to 8 units, and we also know that the radius of this big circle equals to 2r, while the radius of this small circle equals to r, and we want to find out the size of r, or the value of the radius of this small circle. Okay, so first of all I will present to you two new rules. The first rule will be rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. I will read rule number 1 again. Rule number 1 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So actually, if we have a circle and suppose that the center of this circle is at this point, and it is point O. It is defined as point O, and we have tangent to this circle actually tangent AB is tangent to this circle at point M, and we also have radius this radius R. This radius is actually drawn to the point of tangency. That is to say, point M is the point of tangency, so this radius is drawn to the point of tangency. Therefore, according to rule number 1, the tangent AB, this tangent AB, is perpendicular to this radius. That is to say, this angle is equals to 90 degrees, and this angle also equals to 90 degrees. Again, whenever you have radius that is drawn to the point of tangency, like in this drawing, then the tangent will be perpendicular to this radius. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So that is the meaning of rule number 1, and I will present to you also rule number 2. According to rule number 2, if from one external point two tangents are drawn to a circle, then they have equal lengths. So I will read rule number 2 again. Rule number 2 states that if from one external point two tangents are drawn to a circle, then they have equal lengths. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have a circle and this point P is an external point in relation to this circle. This point P is neither inside the circle or on the circle. Therefore, point P is considered as external point in relation to this circle. So if from the external point P you draw two tangents to this circle, so this will be the first tangent. We will define the touching point between this tangent to the circle as point A. And we will draw also the second tangent to this circle. We will define the touching point between this tangent to the circle as point B. Then, according to rule number 2, whenever you draw from an external point like this point, point P, that is external point, whenever you draw two tangents to a circle, then the length of those two tangents will be equal to each other. That is to say, the length of this tangent is PA. The length of this tangent will be equal to the length of this tangent. The length of this tangent is PB. So according to rule number 2, PA equals to PB. Again, whenever you draw from one external point two tangents to a circle, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. PA equals to PB. The length of those two tangents are equal to each other. That is actually rule number 2. So, in the next step, we will define the center of this small circle as point P, and we will define the center of this big circle as point Q, and we will join together points A and P by a straight line. We will define the touching point between tangent AB to the small circle as point M, and we will join together points P and M by a straight line. Actually, line segment PM is the radius of the small circle because of the fact that line segment PM starts from the center of the small circle, that is to say from point P, and ends at point M, that is the point on the circle itself. For that reason, PM is the radius of the small circle. I will name it as R, the radius of the small circle, and then we will define this point as point E. So the tangent AE, or the touching point between the tangent AE to the small circle, will be defined as point N. Then we will join together points P and M. We will join together points P and N by a straight line. Actually, Pn is the radius of the small circle because of the fact that line segment PM starts from the center of the small circle, that is to say from point P, and ends at point A, at point N, that is a point on the circle itself. Therefore, line segment PM is the radius of the small circle, so it equals to R. And actually, this radius is drawn to the line, this radius is drawn to the point of tangency, that is to say point M. Point M is the point of tangency of tangent AB. Therefore, because of the fact that this radius is drawn to the point of tangency, according to rule number 1, the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees. And this angle also equals to 90 degrees. Okay, so as I already said, whenever the radius is drawn to the point of tangency, then the tangent will be perpendicular to that radius. That is to say, this angle is 90 degrees and this angle is also 90 degrees. And for the same reason, we have this radius that is drawn to the point of tangency, that is to say point N. Therefore, the tangent AE will be perpendicular to this radius, that is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, so actually we will prove that those two right triangles can go into each other. Okay, so we will prove actually that the right triangle, triangle AMP, is congruent this is the sign of congruent. So the right triangle, triangle AMP is congruent to the right triangle, triangle ANP. I will repeat again. We will prove that the right triangle AMP is congruent to the right triangle ANP. First of all, AM is equal to AN. AM is equal to AN according to rule number 2. AM equals to AN according to rule number 2. According to rule number 2, actually if from one external point, that is to say point A, we have two tangents to the small circle, tangent AM and tangent AM and tangent AN. So according to rule number 2, those two tangents are equal to each other. So whenever you draw from one external point two tangents to a circle, then the lengths of those two tangents will be equal to each other. That is to say, AM equals to AN. So AM equals to AN according to rule number 2. And we also know that PM equals to PN. PM equals to PN equals to the radius of the small circle. PM equals to Pn equals to the radius of the small circle. Okay, and here we have a common side. AP, side AP is a common side, it belongs to both triangles. So AP equals to AP is a common side that belongs to both triangles. Again, AP equals to AP is a common side. So we actually proved that three sides of the right triangle AMP are correspondingly equal to three sides of the right triangle ANP. Therefore, we proved that those two triangles can go into each other according to side rule. So I will write it down. We actually proved that the right triangle AMP is congruent. Again, this is the sign of congruent to the right triangle ANP. according to side rule. So what is side rule? If you prove that all three sides of one triangle are correspondingly equal to all the three sides of another triangle, then you prove that those two triangles can go into each other according to side rule. So from the fact that those two right triangles can go into each other, we will conclude that those two angles are equal to each other. Okay? So I will write it down. Angle PAM is equal to angle PAN angle PAM equals to angle PAN according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding angles will be also equal to each other, that is to say this angle equals to this angle. And if we define angle PAM as alpha, then angle PAN will be also equal to alpha because of the fact that those two angles are equal to each other. So actually we found out that angle PAM equals to angle PAN, and both angles are equal to alpha according to our definition. Okay, so in the next step we will join together points A and Q by a straight line. And we will define the touching point between tangent AE to the big circle as point S, and we will join together points Q and S by a straight line. According to rule number 1, so actually QS is the radius of the big circle because of the fact that line segment QS starts from the center of the circle, that is to say point Q, and ends at point S, that is a point on the circle itself. Therefore QS is the radius of the big circle, so it equals to 2R. So actually this radius of the big circle is drawn to the point of tangency, that is to say point S. Therefore, according to rule number 1, the tangent AE is perpendicular to this radius, that is to say this angle is a right angle, it equals to 90 degrees, and this angle is also a right angle that equals to 90 degrees. And the same thing is true about this radius that is drawn to the point of tangency. We will define the touching point between tangent AD to the circle as point H, and as you can see from the drawing, this radius is drawn to the point of tangency, that is to say point H. Therefore the tangent DA is perpendicular to this radius, that is to say this angle is a right angle, it equals to 90 degrees, and this angle is also a right angle that equals to 90 degrees. Again, whenever you have radius that is drawn to the point of tangency, like in this drawing, this radius is drawn to the point of tangency, that is point H. Therefore the tangent DA is perpendicular to this radius, that is to say this angle is 90 degrees and this angle is 90 degrees. Okay, so in the next step we will prove that those two right triangles can go into each other. So actually we will prove that the right triangle ASQ, this right triangle, is congruent to the right triangle AQH. So I will repeat again, we prove that the right triangle ASQ is congruent to the right triangle AQH. First of all, we know that AS equals to AH. AS equals to AH according to rule number 2. AS equals to AH according to rule number 2. Actually, rule number 2 says that if from external point A is external point in relation to the big circle, so if from external point you draw two tangents to a circle, then they will be equal in their length. As you can see here, we have tangent AS. Tangent AS is tangent to this circle at point S, and we have tangent AH that is tangent to the big circle at point H. So according to rule number 2, whenever you draw two tangents from one external point to a circle, then the lengths of those two tangents will be equal to each other. That is to say, AS equals to AH. Okay, AS equals to AH according to rule number 2. And we also know that QS equals to QH equals to the radius of the big circle, that is actually 2R. QS equals to QH equals to the radius of the big circle, that is actually 2R. QS equals to QH equals to the radius of the big circle, that is 2R. And we also have here a common side. QA is a common side, it belongs to both triangles. So QA equals to QA is a common side that belongs to both triangles. Again, QA equals to QA is a common side that belongs to both triangles, so we actually proved that all three sides of the right triangle ASQ are equal to all the three sides of triangle AQH, are corresponding equal to all the three sides of triangle AQH. So actually those two triangles can go into each other according to side rule. So I will write it down. So we actually proved that the right triangle ASQ is congruent to the right triangle AQH, according to side rule. Okay, so actually, from the fact that those two triangles can go into each other, we will conclude that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two right triangles can go into each other. Therefore, those two corresponding angles will be equal to each other. So I will write it down. Actually, this angle QAS, angle QAS is equal to angle QAH angle QAS equals to angle QAH according to the rule that corresponding angles in congruent triangles are equal to each other. And if we define this angle as beta, then this angle will be also equal to beta because of the fact that those two angles are equal to each other. So we found out that angle QAS equals to angle QAH, and both angles are equal to beta according to our definition. Okay? Actually, here we will define the touching point between the tangent BC to the small circle as point L, and as you can see from the drawing, this radius is drawn to the point of tangency, that is to say to point L. Therefore, according to rule number 1, the tangent BC is perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Okay, and we know that all the four angles of a square are right angles. Therefore, angle ABC, this angle that is one of the four angles of this square, is equal to 90 degrees, so it is a right angle. So we will focus on quadrilateral PLMB. We will focus on this quadrilateral PLMB. Actually, in quadrilateral PLMB, we have three right angles. One, two, and three right angles. So the sum of those three right angles is equal to 90 times 3 is 270 degrees. And we have the rule that the sum of the angles in any quadrilateral equals to 360 degrees, and especially in quadrilateral PLMB, the sum of the angles in quadrilateral PLMB equals to 360 degrees. Okay, so actually the sum of the angles in quadrilateral PLMB equals to 360 degrees. But we have already three angles that the sum of them is 270 degrees. So if we define the fourth angle as angle Z, then 270 degrees, that is the sum of the three angles of triangle quadrilateral PLMB plus the size of the fourth angle must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral equals to 360 degrees. Okay, so three angles, the sum of them is 270 degrees plus the size of the fourth angle must be equal to 360 degrees. So here we will subtract from this equality 270 degrees, and we will get that angle Z equals to 360 degrees minus 270 degrees, it equals to 90 degrees. Okay, so we found out that angle Z, this angle, equals to 90 degrees. It is a right angle. And we actually also have the rule that any quadrilateral that has four right angles, it must be at least rectangle. So as you can see from this drawing, quadrilateral PLMB has four right angles. Therefore, quadrilateral PLMB must be at least rectangle. Okay, so quadrilateral PLMB must be at least a rectangle. According to the rule that any quadrilateral that has four right angles, it must be at least rectangle. The other possibility is that it is a square. Okay, so it must be at least rectangle, and if all of its sides are equal to each other, then it will be not a rectangle but a square. But it must be at least rectangle. Okay? And we know that the opposite sides of any rectangle are equal to each other. Okay, the opposite sides of any rectangle are equal to each other. That is to say, PL equals to MB. PL equals to MB. Again, PL equals to MB according to the rule that the opposite sides of a rectangle are equal to each other. But we know that PL equals to R, so we can write here that PL equals to R. So from this equality, we will derive that MB also equals to R. MB also equals to R. And according to the rule that the opposite sides of a rectangle are equal to each other, PM also equals to LB. PM equals to LB. But we know that PM equals to R. PM equals to R. So from this equality we will derive that LB also equals to R. LB also equals to R. So LB equals to R, that is the radius of the small circle. So actually we know that AB equals to 8 units, so I'll write here AB, that is the side of our square ABCD, it equals to 8 units. Okay, so AB equals to 8 units, and MB equals to R. MB equals to R, as you can see from the drawing, MB equals to R. And what is the size of AM? The size of AM is actually, AB minus MB. Again, AB minus MB equals to AM. So AB minus MB equals to AM. AB minus AB equals to AM. But we know that AB equals to 8 units according to what is given us in the question. AB equals to 8 units. And we know that MB equals to R. So we found out that AM equals to 8 minus R. Okay? AM equals to 8 minus R units. So we can write here that AM equals to 8 minus R. Okay? In the next step, we will define the touching point between tangent DC to the big circle as point G, and then we'll join together points G and Q by a straight line. Actually, QG is the radius of the big circle because of the fact that line segment QG starts from the center of the big circle and ends at point G, that is a point on the circle itself. Therefore, GQ or QG is the radius of the big circle, that is to say, it equals to 2R. And actually, this radius QG is drawn to the point of tangency, that is to say, point G. Again, this radius is drawn to the point of tangency, that is actually point G. Therefore, according to rule number 1, the tangent DC is perpendicular to this radius. That is to say, this angle is a right angle, it equals to 90 degrees. And this angle is also a right angle that equals to 90 degrees, according to the rule that if you have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to that radius. That is to say, this angle is 90 degrees and this angle is also 90 degrees. And again, we have the rule that all 4 angles of a square are right angles. Angle ADC is one of the angles of the square ABCD, therefore it equals to 90 degrees. Angle ADC equals to 90 degrees because it is one of the square angles. In the next step, we will focus on quadrilateral DGHQ. Okay, we will focus on quadrilateral DGHQ. in quadrilateral DGSQ, DGHQ, we have 3 right angles, 1, 2, 3. The sum of those 3 right angles is 90 degrees times 3 is 270 degrees. And we know that the sum of the angles in any quadrilateral is actually 360 degrees. Okay? So we will define this angle as angle Z. So actually the sum of the 4 angles of quadrilateral DGHQ equals to 360 degrees, and we have already 270 degrees plus the side of angle Z must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equals to 360 degrees. So the sum of 3 angles plus the side of the 4th angle must be equal to 360 degrees. Okay, so here we will subtract from this equality 270 degrees, and we will get that angle Z equals to 360 degrees minus 270 degrees is 90 degrees. So we found out that angle Z is a right angle, it equals to 90 degrees. So actually in quadrilateral DGHQ we have 4 right angles. Okay, we will repeat on the same process as we did in the small quadrilateral PLMB. We will repeat it on the bigger quadrilateral DGHQ. So in quadrilateral DGHQ, in quadrilateral DGHQ, we have 4 right angles. And any quadrilateral that has 4 right angles, it must be at least rectangle. Okay, so I'll write it down. Quadrilateral DGHQ must be at least a rectangle. Because it has 4 right angles. Okay? And we have the rule that the opposite sides of any rectangle are equal to each other. So DH equals to GQ, DH equals to DH equals to GQ, according to the rule that the opposite sides of a rectangle are equal to each other. DH equals to GQ, but we know that GQ equals to 2R. GQ equals to 2R. So from this equality, we will derive that DH equals to 2R. DH equals to 2R. So here we will write that DH equals to 2R. And the opposite sides, edge Q and DG in quadrilateral DGHQ are also equal to each other. So we will write down that DG, side DG equals to side HQ in quadrilateral DGHQ. DG equals to HQ Okay, DG equals to HQ according to the rule that the opposite sides of a rectangle are equal to each other. And quadrilateral DGHQ is at least rectangle. But we know that GQ equals to 2R. It is from the drawing you can see that GQ equals to 2R. Actually here DG equals to HQ. DG equals to HQ, and we know that HQ equals to 2R. Again, DG equals to HQ, and we know that HQ equals to 2R. Okay, DG equals to HQ, and we know that HQ equals to 2R. So from this equality, we will derive that DG also equals to 2R. DG also equals to 2R. So here DG equals to 2R. And in the next step, we will calculate the value of AH. Okay, what is the size of AH? AH will be equal to DA minus DH. DA minus DH. Again, DH equals to DA minus DH. Okay? DA minus DH equals to AH. Okay? AH equals to DA minus DH. So AH equals to DA. DA equals to 8 units. All the sides of a square are equal to each other. They are all equal to 8 units according to what is given us in the question, that AB equals to 8 units. And DH equals to 2R according to what we found out, that DH equals to 2R. So in total we got that AH or HA equals to 8 minus 2R. Okay? And DG equals and DH AH equals to 8 minus 2R, and AM equals to 8 minus R. Okay, AM also equals to 8 minus R. So, what is the size of angle BAD? The size of this angle BAD, is actually 90 degrees because of the fact that what is the size of angle of this angle? The size of this angle BAD equals to 90 degrees because of the fact that all the sides of a square are right angles, are equal to each other, and they are equal to 90 degrees. They are all right angles. So this is one of the square angles, therefore it equals to 90 degrees. So we will write down that angle DAB, this angle, equals to 90 degrees because of the fact that all four angles of a square ABCD are right angles. They are equal to 90 degrees. Therefore, angle DAB equals to 90 degrees. But as you can see from the drawing, angle DAB consists of four angles: alpha, alpha, beta, and beta. So the size of angle DAB is the sum of those four angles. So angle DAB also equals to 2 alpha plus 2 beta, angle DAB equals to also to 2 alpha plus 2 beta. Again, angle DAB equals to 2 alpha plus beta, and we know that angle DAB equals to 90 degrees because it is one of the squares angles that are, therefore it is a right angle that equals to 90 degrees. So actually we will have equation number 1 that states that the sum of those 4 angles, 2 alpha plus 2 beta, is equal to 90 degrees. Okay, 2 alpha plus 2 beta equals to 90 degrees. Okay, this is a right angle, and this angle consists of 4 angles, so therefore actually you can say that 90 degrees is the sum of the 4 angles. That is to say 2 alpha plus 2 beta equals to 90 degrees. Here we will divide the equation number 1 by 2, and we will get that alpha plus beta equals to 90 degrees over 2 is 45 degrees. We found out, according to equation number 1, that alpha plus beta equals to 45 degrees. But if alpha plus beta equals to 45 degrees, then tangents alpha plus beta will be equal to tangents 45 degrees. Again, if alpha plus beta equals to 45 degrees, then tangents alpha plus beta will be equal to tangents 45 degrees. Very simple. Okay, so we know that tangents 45 degrees is 1. So we got in the question number 1 that tangents alpha plus beta equals to 1. Okay, tangents alpha plus beta equals to 1. We actually have trigonometric identity for the value of tangents alpha plus beta. Actually, according to the following trigonometric identity, the value of tangents alpha plus beta is actually tangents alpha plus tangents beta over 1 minus tangents alpha times tangents beta. Okay, so actually we can substitute tangents alpha plus beta in equation number 1 by this expression that equals to tangents alpha plus beta according to this trigonometric identity. So we will do it now. So instead of tangents alpha plus beta, we will write down this expression, and it will be equal to 1. Okay, so equation number 1 will be, instead of tangents alpha plus beta, we will write down this expression. Again, we substitute the tangents alpha plus beta by this expression because this expression equals to tangents alpha plus beta according to this trigonometric identity, and it equals to 1. Okay, so in the next step we will find out the values of tangents alpha and tangents beta from the drawing, and we will substitute tangents alpha and tangents beta in equation number 1 by the values that we will find out for tangents alpha and tangents beta. Okay? So we will focus on the right triangle, triangle AMP. So in the right triangle, triangle AMP, what is the value of tangents alpha? Tangents alpha is actually equals to PM over AM. Again, in the right triangle, triangle APM or PAM, tangents alpha equals to PM over AM. But the value of PM is R, and the value of AM is 8 minus R. So in total we found out that tangents alpha equals to R over 8 minus R. We found out that tangents alpha equals to R over 8 minus R, and we will find out also the value of tangents beta. We will focus on the right triangle, triangle AHQ. So in the right triangle, triangle AHQ, tangents beta equals to HQ. HQ over AH. Again, in the right triangle, triangle AHQ, tangents beta equals to HQ over AH. But what is the value of HQ? HQ equals to 2R, and actually we will calculate the value of AH. And the value of AH, actually we know that DA is one side of square ABCD, therefore it equals to 8 units. DA equals to 8 units, and DH equals to 2R. Again, DA equals to 8 units and DH equals to 2R. So what is the value of AH? AH, from the drawing you can see that AH equals to DA minus DH. DA minus DH. Again, according to the drawing, AH equals to DA minus DH. AH equals to DA minus DH. Okay, and DA equals to 8 units and DH equals to 2R. So AH equals to 8 minus 2R. 8 minus 2R. AH equals to 8 minus 2R. So in total we found the tangents beta equals to 2R over 8 minus 2R. again, we found out that tangents beta equals to 2r over 8 minus 2r, and tangents alpha equals to r over 8 minus r. So we will substitute tangents alpha and tangents beta in equation number 1, this equation number 1, by the values that we found out for tangents alpha and tangents beta. Okay, so we'll do it now. So here we have question number 1, tangents alpha, and the value of tangents alpha is r over 8 minus r plus tangents beta. The value of tangents alpha, according to what we have already found out, is 2r over 8 minus 2r all divided by 1 minus tangents alpha times tangents beta. So we actually substituted the values of tangents alpha and tangents beta by the values that we found out for tangents alpha and tangents beta, and we got this equation. So here we will, in order to find out the value of r, we will do a common factor to those two expressions, and we will also do a common factor to 1 and this expression. Okay. So actually the common factor for these two expressions will be 8 minus r times 8 minus 2r and what we will have in the numerator, we have to multiply r by 8 minus 2r, and we will get this expression is actually equals to this expression and we will have to multiply 2r by 8 minus r, and actually this expression is equals to this expression, okay, and all divided by 1 minus these expressions. So we will create a common factor for 1 and this expression. We will substitute 1 by 8 minus r over 8 minus r. It equals to 1, of course, and we will multiply it by 8 minus r over 8 minus r, that is also equals to 1. So actually this expression equals to 1. So, and then we will have to subtract from 1 this expression that is actually 2r squared. 2r times r is 2r squared, all equals to 1. Okay, so here we have 8 minus r times 8 minus 2r, and we have also the same expression here. So those two expressions will get cancelled. So, and what is left after we cancel those two expressions? Here we will open the brackets. R times 8 is 8r. R times minus 2r is minus 2r squared, plus 2r times 8 is 16r. 2r times minus r is minus 2r squared, all divided by, we will open these brackets. 8 times 8 is 64. 8 times minus 2r is minus 16r. Minus r times 8 is minus 8r. And minus r times minus 2r is 2r squared. Minus 2r squared equals to 1. So we actually opened the brackets here and we got this expression. Here we have 2r squared minus 2r squared is 0, so those two expressions are equal to 0, so they will cancel. And so here we have in the numerator 8r plus 16r is 24r. Minus 2r squared is minus 4r squared over 64 minus 16r minus 8r is minus 24r equals to 1. So here we will cross multiply this expression and we will get that 24r minus 4r squared equals to 64 minus 24r. Here we will add to this we will subtract from this equality 24r, and we will get that minus 4r squared equals to minus 48r plus 64. We will add 4r squared to this equality and we will get a quadratic equation that 4r squared minus 48r plus 64 equals to 0. We will divide this quadratic equation by 4 and we will get that r squared minus 12r plus 16 equals to 0. So we got this quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula that x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay, so in our specific quadratic equation, the variable x is actually r, the radius of the small circle, and the coefficients a, b, and c. A equals to 1, b equals to minus 12, and c equals to 16. So we will put the data inside this expression in order to find out the value of r. We will get that x equals to r, so r equals to minus b, b equals to minus 12, so minus 12 is plus 12, plus minus root of b squared, b is minus 12, so minus 12 square is 144, minus 4 times a, minus 4 times 1 is minus 4, minus 4 times 16 is minus 64, all divided by 2 times 1 is 2, so we got that the radius of the small circle equals to 2L plus minus 144 minus 64 is 80 over 2. So we got this expression. Actually 80 equals to 4 times 20, so I will write it down. R equals to 12 plus minus root of 4 times 20 over 2. The root of 4 is 2, so we write it down. R equals to 12 plus minus the root of 4 is 2. In the root we have left only with 20 over 2. And so actually R equals to 12 over 2 is 6, 2 over 2 is 1, plus minus 20 equals to 4 times 5, and so the radius of the small square equals to 6 plus minus the root of 4 is 2 times root 5. So we actually have two possibilities for the value of the radius, the size of the radius. It either equals to 6 plus 2 times root 5 or to 6 minus 2 times root 5. So I write it down. The radius can be equal either to 6 plus 2 times root 5, or the radius also can be equal to 6 minus 2 times root 5. But we know that the size of the side of a square, of that our square, is equals to 8 units. And as you can see from the drawing, the small circle and also the big circle located inside the square. So the radius of the small circle must be less than the size of one side of the square. That is to say, the radius of the small circle is less than 8 units, because 8 units is the size of one side of the square. So R is less than 8 units, but here one of the roots of the quadratic square is a6 plus 2 times root 5, that is greater than 8. But the radius must be less than 8, so this possibility is incorrect, and we left only with the answer that R equals to 6 minus 2 times root 5. So we found out that the radius of the small circle equals to 6 minus 2 times root 5, or in terms of numbers, it actually equals to 1.53 units. Okay? So the answer to the question is that the radius of this small circle equals either to 6 minus 2 times root 5 units, or in terms of numbers, the radius of this small circle equals to 1.53 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this small circle, and in order to find out the radius of this small circle, I presented to you two new rules, and actually the first rule says that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. Again, according to rule number 1, a radius to a circle is perpendicular, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So here we have a circle, the center of the circle is at point O, and we have the tangent AB, the touching point, the tangent AB is tangent to this circle at point M, and we have this radius that is drawn to the point of tangency, that is to say to point M. Therefore, the tangent AB will be perpendicular to this radius, that is to say this angle is 90 degrees and this angle is 90 degrees. Okay, so that is rule number 1, and we have also rule number 2 that states that if from one external point two tangents are drawn to a circle, then the lengths of the two tangents are equal to each other. So the meaning of rule number 2 is actually that if you have external point of this circle, that is to say from point P, you draw two tangents to this circle, then the lengths of those two tangents are equal to each other, that is to say AP equals to BP or PA equals to PB. Okay, then we actually proved that those two angles can go into each other, those two right angles can go into each other, therefore if this angle is alpha, this angle is also alpha, according to the rule that corresponding angles in congruent angles are equal to each other. And we also proved that those two right angles can go into each other, Therefore, according to the rule that corresponding angles in congruent angles are equal to each other, those two angles are equal to each other, and if one angle is better, then the other angle will be also equal to beta. Okay? And we know that all the four sides of a square, all the four angles of a square are right angles, so this is a right angle, it equals to 90 degrees, but it also consists of four angles. So this angle that equals to 90 degrees equals also to 2 alpha plus 2 beta. So 2 alpha plus 2 beta equals to 90 degrees. We divided this, the equality, by 2, and we got that alpha plus beta equals to 45 degrees. 2 alpha plus 2 beta equals to 90 degrees, therefore alpha plus beta equals to 45 degrees. And if alpha plus beta equals to 45 degrees, then tangent alpha plus beta will be equal to tangent 45 degrees. Okay, and we know that tangent 45 degrees is 1, and tangent alpha plus beta equals to this expression according to this trigonometric identity. So we substitute the tangent alpha plus beta by this expression, and we got this equality. Then we calculated the value of tangent alpha and tangent beta, and we put inside this equality the value that we found for tangent alpha and tangent beta, and we got this equality. We solved this equation number 1 that is actually has only one variable. That is very simple to solve, and we got two answers. The first answer is that the radius of the small circle equals to 6 plus 2 times root 5, and the second answer is that the radius of the small circle equals to 6 minus 2 times root 5. But because of the fact that that one side of this square equals to 8 units, and the small circle is inside the square, therefore its radius must be less than 8 units. So this answer that the radius of the circle equals to 6 plus 2 times root 5, that is greater than 8 units, it is not correct, because the radius of the small circle must be less than 8 units. Therefore, the only possibility that is left is that the radius of the small circle equals to 6 minus 2 times root 5 units, or in terms of numbers, the radius of the small circle equals to 1.53 units. Again, the radius of this small circle, this radius equals to either 6 minus 2 times root 5 units, or in terms of numbers, the size of this radius of the small circle equals to 1.53 units. Okay? Thank you very much.